Okay, everybody. I hope you're doing well. I wanted to do a video about distillation. I didn't find anything online that I liked very well. So this may be a series of a couple of videos. I'm not sure how to do it exactly, but let's start with the setup. So I've already gotten a lot of the equipment out of the container. And so I wanted to show you that it kind of, see if I can pull this just a little bit closer for now. Everything fits together. So this right here that I'm holding is the condenser tube. So let's start with that. The condenser tube, you may or may not be able to see it. I'll kind of come in close here. Is a double tube. So there's an inner tube and then an outer tube. The outer tube is connected to this orange tube, which feeds water into it. And then the inner tube is where the reaction takes place. So let's see if I can back that up again. So that hooks into my main, I guess I should have started over here, but this is my main container here. This is the distilling flask. That's where my substance is that needs to be distilled. One thing that's important to remember about it is that you should never fill it more than half full. If it's too little, like a less than a third filled, then you're going to be taking a long time to distill it. But if it's more than half filled, you're probably going to be in trouble, because what happens is it'll kind of spit back out when it boils, and you may get some contaminant. So about 1/3 to 1/2 full is what you want to do. So today, since we're distilling about 35 milliliters, 100 ml flask is perfectly fine. So what we're going to do is put the material that needs to be distilled in here. This is the little, I don't know what you call it, some kind of tube, and it connects. So when it boils, it's going to come up here. I've got a thermometer that's attached. This is the thermometer head that I can take out and fit in there. And one thing about the thermometer is that you want to make sure that the head of the thermometer, let's see if you can see that, is below this arm right here. Because what's going to happen is the vapor is going to come up. It's going to, and then right here, we're going to have cool water circulating in the outer jacket of the condenser tube. And so when it hits here, it's going to feel that cool temperature, and it's going to condense back. So it boils, but it condenses in here. And then it will run through here. And then it will drop out this end. So let's see if you can see that. Okay. Now you can collect it a number of different ways. In this lab, we need to measure the volume that's coming out over time. And so what I've got is a volumetric flask. You could also, depending on what you want to catch it with, you can also use another little round bottom flask to catch it with. You could use a beaker. You could use probably an Erlenmeyer flask would be better, because you don't want it to spill out. But like I said, today we're going to be measuring it with a volumetric cylinder, graduated cylinder. And notice how, let's back this up a little bit. See the whole scenery here. So I've got it clamped a few places. So I've got this, the bottom flask clamped here. These are nice little universal clamps, because they can be tightened and turned any which way, because there's like 4 different screws on it, 3 or 4 different screws. And so right now I've got the bottom flask, which is really a good place to clamp it. If you don't clamp it here, and if you have the bottom stuck, there's other ways that you can do it. There's clamps, which I'll show you in a second, that you can hold it on. But right now I found this little nifty device. This is right here that I've never seen before. So that's the upside of coronavirus. Is back in the spring, when I was watching other people doing videos, I saw this, and this is really nice because I can actually raise my heating. This is my heating element. I can raise or lower my heating element without adjusting my, which used to be a really hard thing because if you overheat this, you want to be able to remove the heat right away. And so this is really nice where you can turn it down and get the heat off right away. All right, so I've got my distillation flask and it's connected to this, I guess, a Y tube. And then that's connected into the condenser tube. Now these should be held together pretty well. And so one thing you can do is a rubber band, or you can use this. This is a clasp where one side is a little bit bigger than the other, and so it actually fits right over here. The fatter side goes on the fatter side, and so that holds it together. Before I put this all together, one thing I did was I got some stopcock grease and I just ran it over all the fixtures where they're attaching, so that hopefully none of the vapor will escape. So I'm going to, let's move that up again. I'm going to clamp this side as well so that it doesn't come apart. All right, so, and this is my thermometer head, like I said. And also you don't want the thermometer head to be too high because then you won't be getting the temperature of the boiling point. So you want it to drop. You don't want it way down in there, but you want it to be below this juncture right here. One way that I did that is I put a little of this parafilm onto the thermometer because it would drop through otherwise. And then I'll be able to read the temperature very easily. And what I'm going to do in this distillation is I'm going to record the amount that I got, the volume that comes out, versus the temperature. One more thing I wanted to tell you about is when you set up this condenser tube, one thing you want to do, so these tubes right here are what, you probably can't see me doing that. These tubes are what connect to the water. This is a sink right here. So the water is coming out of here and it is going into the water jacket. And then it will come out the top and go in. And you always want to make sure that the water's coming in the bottom and going out the top. So that's another thing to watch. So let me turn my water on. You want to do it really carefully once you're pretty sure you got everything. Okay, I'm going to put some water. Sometimes it flows. There it goes. See if you can watch it. If I get it flowing, it's going to come. So it's coming up in there. And it's going to be draining out. Going to be draining out the top. And so now this is cold water that's running through that. So that's what's going to condense the vapor. Let me pause it here and get everything ready. This again is a simple distillation. And so what you notice, I just have the thermometer here and the distillation flask and the condenser. So pretty straightforward. You usually do a simple distillation if the boiling points of the two liquids are very far apart, or if you're trying to separate something from a non-volatile liquid, so then their boiling points would be very far apart. That's not the case here, but what we're trying to do is to compare a simple distillation to a fractional distillation. So we're going to start with the simple distillation. So let me pause here a second and get ready to put my stuff in the flask. Okay, so I have 15 milliliters of cyclohexane and 20 milliliters of toluene. I'm not pipetting it, I'm just measuring. I measure pretty accurately with a volumetric flask, so I think we can safely say to 1 decimal place. I think that's all we need for today. So another thing that you definitely want to do when you're doing a distillation is you need to put in some boiling stone. So this is called a boilizer. It's a non-volatile granules. See if you can see it in my hand. They're little white porous rocks. And what they do is they help, when it starts boiling, sometimes the boiling solution can bump or kind of bump. And what you don't want that to happen because it can splash and spill and everything like that. So what this does is it helps get a really smooth boil. So I'm pouring in 20 mils. I've got a funnel here so that I don't make a mess. So I've poured in 20 milliliters of toluene and 15 milliliters of cyclohexane. Shoot. And that's what you're not supposed to do. I just poured it through my condenser. So let's go away. So really you should have put this in there before you clamped it. I was trying to go a little faster, and that's what happens when you do that. All right. All right, so when you do something to try to speed things up and you mess up, it actually takes you more time. So I actually paused the video and cleaned out the tube to make sure that there was nothing still left in it. So now I have my cyclohexane and toluene in my flask. Everything's sealed up. I'm going to go ahead and I've got the clamps there. All right, so the next thing I'm going to do, and I've got the water flowing through here. So the next thing I'm going to do is I'm going to turn my heat up fairly high so that they can boil. I should say, and then I'm going to put it kind of nests in there. So this is a heating contraption, and I've got it up there, and I've got, let's see if we can see that. I've got the flask sitting down in the nest. So it's going to heat up. I've got it turned up pretty fast. What I'm going to do is once it starts boiling, I'm going to see if I can get this just a little bit closer. Once it starts boiling, I'm going to probably turn it back a little, because what you can do is you can monitor the flow. You want it to drip out at about 1 to 2 milliliters per minute. So if it's coming too fast, then you can turn back the heat. But at first, you can heat it vigorously. While I'm waiting, I'm going to move some of my stuff out of the way. Now I want to collect about 30 milliliters of my distillate, and I'm going to record it every, 1 to 2 milliliters. So when it starts dripping out, I'll start taking my recordings of the volume. But it's going to take a little while, so I may again pause it here and get you back when the action's going. So things are heating up a bit. If I go in here, you can see that the liquid is boiling. If you look at the temperature, though, it still says it's a little bit higher than room temperature, but it's still pretty low. One thing I mentioned is make sure that your thermometer is not touching the glass at all, because then you'll be taking the temperature of the outside. But I'm watching, all of a sudden, the temperature is jumping. And so what's happening, if you can see it, if you get in close, you can sort of see the vapor is starting to rise up into this area. So suddenly the temperature's jumping. It's jumping up to about 67, 68. I don't have any drips yet of anything, so now I'm going to watch and see. I'm going to watch to see if I can see my first drip coming down here. Or, yep, I see one. I see it. It's coming down, and it's about to drip out there. And so the temperature of my first drip is 75.4. And now I'm going to wait until it's coming out fairly fast, so I think I'll turn the heat down just a little bit. So now what I'm going to do, I'm going to wait till I get to about a milliliter. I need to turn this so I can read it. So I'm about 2 milliliters now, and my temperature is 77.4. And I'll just keep going you can see it, it's working pretty hard. I don't know if you can see it dripping. I'll get closer in here. And it's still boiling. The temperature is, so right now I've got about 3 about 3 milliliters, and the temperature 77.9. I'm going to keep going till I have about 30 milliliters, so this might take a while. I might pause it in a minute. And so I'm going about every mill to mill and a half. Right now I'm at about 4.5 and the temperature is 78.0. By the way, the official temperature of cyclohexane is about 80.4, I think. I have to look that up. 80.7. And the boiling point of cyclohexene, the literature value, is 110.8, so much higher. And if you remember, now my boiling point might be a little bit low because if you remember when we're in the mountains, let's take a reading. So I'm at about 6 milliliters and my temperature is still 78. If you remember, we're in the mountains, so I think we're at the boiling point of the cyclohexane right now. And we can adjust it a little bit if we needed to know the absolute value. I'm going to turn it back up again because it's slowed back. We could do an adjustment, which I can tell you about later. But right now, this is good. All right, so now we're at about 9 milliliters. I'm kind of slacking off, and it's still at 78. About 10 milliliters, 78. It's weird, the water sounds like popcorn, and I keep thinking I'm forgetting to take it off of the plate, off the hot plate. All right, let's see, we're at about 12 milliliters. And again, 78. $13 milliliters, 78.1. $14 milliliters. Okay, 15.5. I'll give you this data when I'm for you to write it up. All right, I gotta make sure it's still boiling. It's still boiling. We should see the temperature rising. All right, now we're at about 23 milliliters. And the temperature's starting to rise. Again, because of the higher temperature, I have to kick the heat up. 25 milliliters. All right, I'm going to swap out my container, which I don't have a good container here. So let's see, I'll do this one. The smell has changed. There, it's starting to jump now. So we're at, I think I'm going to go to about, all right, so now we're at 2.8, 28.8, and it's 81.5. Okay, I'm at 29 milliliters and it's 84.6. It's dripping a little slower, so I'm going to take one at maybe 29.5 milliliters, 87.1. All right, I'm at 30 milliliters. All right, I'm about to stop it off. I'm going to let it go for a little bit, but I'll pause it and come back. All right, so I've just about finished. And so I have lowered the heat. You don't want to distill to dryness because the glass could shatter. So what I'm going to do is I'm going to stop the video. I'm going to start another video and we'll do the fractional distillation.